Welcome to a special episode of the Math Ed Podcast. I'm your host, Sam Otten, coming to you proudly from the University of Missouri. Recently, I was very happy to return to my alma mater of Michigan State University for the annual PMENA conference held in early November in East Lansing. While there, I attended the working group on argumentation, justification, and proof. This working group was organized by Michelle Cirillo from the University of Delaware, Megan Staples from the University of Connecticut, Karl Kosko from Kent State University, Jill Newton from Purdue University, and Keith Weber from Rutgers University. You can find their working group paper in the PMENA proceedings. It's entitled Conceptions and Consequences of What We Call Argumentation, Justification, and Proof. On day one of this working group, Keith Weber gave a short presentation based on what he has learned working on the upcoming handbook chapter. He was gracious enough to allow me to record his talk and present it to you here on the podcast. I also recorded the panel discussion that occurred on day two of the working group, and I will share that on the next episode. Now I will pass it off to Dr. Keith Weber in a crowded room on the campus of Michigan State University.
The last year and a half, Gabriel and Andreas Filanides and I were writing a review for the upcoming chapter on justification and proof for the handbook, which I just found out is now not going to be called the handbook. It's going to be called a compendium or something strange like that. We found that justification and proof pose some unique challenges. As Michelle and Megan were saying, there's a wide number of conflicting definitions of proof used in the literature. And not only are people often not explicit about which definition that they're using, in our own reading of some of the articles, people will say one definition, but as you read, the definition sort of drifts throughout the article. There's a couple of quotes that I really like. David Reed said, "Surveying this literature can be a dizzying experience, juxtaposing claims that secondary students do not prove with claims that primary school children do." We also have that a proof is essentially an argument that convinces mathematicians, but proof is not necessarily a prerequisite for conviction. To the contrary, conviction is far more often a prerequisite for finding a proof. And these aren't just stray or idiosyncratic citations. The idea that proof is conviction is one of the core ideas in our field, and the de Villiers paper has been cited 300 times. So it's tough to review a field where the fundamental premises are that X is true and X is false. So what we tried to do is we tried to sort the field into research along three broad perspectives based on what they're trying to accomplish. And to borrow the language of Anna Sfard, we called it three broad research perspectives on justification and proof, and the dangers of choosing just one. In that sense, that we believe each of these perspectives offer something very valuable to work with that isn't contained in the other perspectives, and we'd be losing a lot if we didn't consider them seriously. So by these perspectives, what we were trying to do was identify common goals, methodologies, constructs, and assumptions used by bodies of researchers to investigate similar issues. I should make two caveats. The first is, when we called something in one of these perspectives, we were talking about the study itself, not necessarily the author. And second, we were going by our impressions of the type of assumptions and work that undergirded these studies. Again, these might not be shared by the authors. So Schoenfeld's work on heuristics, for instance, would be reclassified under the perspective of proving its problem solving. We do not wish to mean that Alan Schoenfeld doesn't care about the meaning that students give to proofs. He certainly does, and that shows up in other work. It's just our impression of how we would classify that study. So what we looked at for each of these bodies of work is what constituted a proof in that study. What were the ultimate goals of the math educators in that study? What were math education people trying to find out? And by what standard would we judge instruction to be successful? And what sort of intermediate questions and constructs are we using to try to accomplish these goals? And then finally, how is argumentation interpreted with the proving activity within each of these perspectives? The first one we're going to talk about is problem solving. So in problem solving, students are given proving tasks, and these tasks are considered a special type of problem solving task. And the researchers here tend to take an observer-oriented or expert-oriented lens about how students are trying to solve those tasks and what a correct or adequate solution to that task means. So what counts as a proof is generally treated as unproblematic. It's the argument that a mathematician or knowledgeable person would count as a proof. So the way that they might address this is they might have two different raters look at the same proofs to make sure, or the same arguments, to be sure they were classifying things the same way. but they tended to avoid giving precise criteria. The criteria that is presented tends to say that they start from some type of assumptions and build a chain of reasoning using valid methods of inference that get to the conclusion, but what constitutes a valid inference or an appropriate inference is usually not said much beyond that. And the issue of what a proof represents to the student or the student's motivation for trying to engage in this isn't usually considered. This is just a task that we want students to be good at and we expect them to solve. And in terms of argumentation, I would argue that, I would say that there's not much there, to avoid overusing the word. I would say there's not much there, and indeed, this perspective generally does not consider the agency of the person receiving the proof. It's a grader who says that this task was successfully completed, or it was not. So the goal here is to design instruction so if we give students proving tasks, they can produce these proofs a large majority of the time, or if we give them other proof-related tasks. So if I give you an ostensibly deductive argument and said, Paul, is this a valid proof or not, he would give the answer that is normatively accepted as correct. The way that this is conceptualized is that there's a set of competencies that you need in order to complete these proving tasks successfully. So what researchers tend to try to do is identify what these competencies are, often but not always by studying experts, and then developing instruction where these competencies are taught to the students. An example of this research is John and Andy Selden's work with proof frameworks. So one of the things that John and Annie noticed in proofs, when you're writing a proof or reading a proof, is that once you have the statement in the proof method, the first few lines and the last few lines of the proof are determined for you. And in a sense, you could even produce those procedurally without knowing what the concepts that they're discussing mean. So they give an example here. This is a good one of their examples, that you have this statement, and it's a if-then, it's a conditional statement. And if you were to write a direct proof of this, you know that you would have to begin by assuming the antecedent and then concluding or arriving at the conclusion. And in fact, if you just follow the normal procedures associated with this, you actually get almost a complete proof. They leave the part in the middle that they call the problem-solving process, but the first 3 lines and the last 4 lines essentially write themselves. And while they're saying not all of proving is procedural, their contention is that if you don't have these procedures, you're going to have a very difficult time. So what they do is they provide evidence that students indeed have difficulty with these tasks, and they also teach math majors how to prove by explicitly engaging in this type of proof framework in a style they call the formal rhetorical part of writing a proof. So the key things to take away here: Selden and Selden identified a competency that was needed for proof writing effectiveness. They studied the competency at a fine enough grain size that they could convey how this competency is done to their students, and then they taught the students to learn that competency. As an aside, I'm not saying this has to be the case in this perspective, but this idea of successive approximation, or teaching by modeling the skill and then giving you scaffolding while you practice the skill with disciplined repetition, is a common way that this is taught, that proof writing is taught in this perspective. Moving on to the second perspective. This is probably the one that's dominant in math education currently, but the idea is a proof is a convincing argument. So you see a lot of claims of this type with the variance being on who it is that is actually being convinced. And while this work has been going on at least since the late 1970s, Harrell and Sauter wrote a very famous article that really crystallized this perspective with the idea of proof schemes. And my colleagues and I said perhaps the biggest advance of the article is students' inability to write proof is not conceptualized just as a deficiency in problem solving, but actually having different epistemic cognitions. So in this perspective, a mathematical proof is usually defined as a deductive proof on the grounds that it's deductive reasoning and not empirical or authoritative reasoning that convinces mathematicians. Now, some things that this perspective generally does not look at is what students do when they reach impasses when they write a proof because they can't decide what to do next. The types of attempted valid reasoning that contains logical error, or even the correctness of the proof that students hand in is recorded, but it's somewhat less important. The idea here is what's the type of evidence that students present, and the implicit assumption seems to be if you get students to know what the product is that we're looking for, they'll eventually be able to figure out how to make that product. So the ultimate goal of instruction in this case is to get students to recognize the limitations of empirical and authoritative and other types of reasoning, and to appreciate the generality and power of deductive reasoning. Pivotal to answering this question is to try to understand what types of arguments that it is that actually does convince students. I can show you a couple of very representative research studies of this type. So Riccio and Godino asked 429 first-year university students, and they gave them a particular general task that they wanted the students to justify. Then they classified the justification. In this case, 43% of them were example-based, and said, we've identified one of the problems. 43% of the population is convinced by example-based arguments. And similar results have been found in other studies, large-scale studies with middle school students, for instance, and secondary students. In terms of helping students, the Andreas and Gabrielle did is fairly typical. The idea was they showed students a task that invited some type of empirical generalization. And this is one of those tasks where the first 5 terms of the sequence are 1, 2, 4, 8, and 16. And this naturally leads students to say, this is just going to keep doubling. Then the next case is 31, so it throws them into a state of disequilibrium. So then they challenge empirical reasoning, and they're given the statement for all natural numbers, n 1,141 n squared plus 1 is not a perfect square. Well, that turns out to be false, but the first counterexample is 10 to the 25th, so nobody's going to go and check all the cases. So this shows that example-based reasoning is fundamentally inadequate. And then they come to see the power of deductive evidence. So the reason that these studies were representative is, first, we often would give students some type of justification-based task, either read a justification or produce it, and then use students' responses as a lens into their standards of what's a convincing or persuasive argument. The instruction generally wants students to see the limitations of empirical or other types of reasoning and the power of deductive reasoning. And although this doesn't have to be the case, as opposed to the other stuff with the problem-solving approach, which is successive approximation, modeling, and scaffolding, this tends to be based on the Piagetian idea where you want to give students some experience where they see the light. Like, I see the error of my ways. I should be reasoning deductively. The third perspective that we described is proof as socially embedded activity. And as opposed to the other two perspectives, these made some assumptions about what proving is to mathematicians and should be to students. So the first one is it should be answers that would receive credit. And the second is proof is a convincing argument. The third perspective takes a step back and actually problematizes that question. So what is proving to mathematicians or high school geometry class or a student in calculus? Why don't we go and see what that is, usually from a socio-constructivist perspective? So one of the goals for the researchers is actually to figure out what proving is within these various cultures. And I point out that the field here, there's been less work in this perspective than the others, so this field is still emerging. One end of it is to look what proving is to mathematicians. This is where the de Villiers quote comes in, that to mathematicians, the role of proving is not solely or even primarily to convince, but to increase understanding and to develop problem-solving techniques. They also found that, we also found that sourcing in mathematics is common. So when you're deciding about whether a proof is acceptable, it's actually common to see if the proof is published somewhere, who wrote the proofs, what authority they have. So it might surprise some of you to know that in mathematics, they don't do double-blind review. They actually view the author of the proof as a very important piece of information in deciding the validity of it. If I handed a proof in about a famous math theorem, they would judge that with a much more critical eye than if it was somebody who had a reputation and who was able to do such things in the past. With students, people have also looked at the classroom-based proofs. One paper that I particularly liked was Herbst and Brock were trying to see what is proof to high school students. And by giving them tasks, they found that the high school students primarily saw proving as a chance for the teachers to assess their abilities to reason logically and to communicate coherently. And also much of the creative work that to mathematicians went involved in the proof, such as constructing auxiliary lines, choosing starting conditions, even choosing the conjecture to be proven, was viewed as out of bounds by the students. Like that wasn't what they were responsible for doing. So the interventions are usually take place over the time in classroom communities where the classrooms come to negotiate more productive norms for writing proofs. And further, the reason that the participants are engaged in writing proofs isn't just settling arguments or gaining conviction, but also gaining other epistemic benefits from proofs as well. So one overarching comment in the way that this leads to confusion is my colleague Carolyn Marr and her former doctoral student, Amy Martino, wrote a famous paper, and I don't know if you're familiar with this, but it involved a 5th grade student named Stephanie writing a very sophisticated proof by cases for a combinatorial statement. And this has had a lot of impact in the field of math education. In fact, this is frequently cited as an example that young students are capable of proving. On the other hand, if you looked at the argument, it was an argument that was convincing and deductive in a sense, but it relied on pictures. It wasn't presented in a conventional form. It was a letter to a friend. And there was no explicit attention to what was being assumed and what was being proven. And these were all things that other researchers say is central to proving. So it's interesting to ask, if we do say that college students had trouble proving, but the students in Carolyn Marr's study didn't, would the college students be capable of producing Stephanie's argument? And how would mathematicians or researchers doing work at the college math level feel if one of their students handed in an argument like that? So having these different standards of proof and different criteria of success can lead to the mismatch and the strange claims in the field that I cited earlier with David Reed, where we juxtapose saying what young students can do and what older students can't. As a final note, and be a little provocative here, one of the ways that I've been thinking about proof is as what Lakoff calls a cluster concept. So what he said is that we tend to try to define categories by finding criteria for inclusion, that the things that meet those criteria are members of the category, and the things that don't are not. So you get like a strict line where you put the good stuff in and keep the bad stuff out. But he also says that most real-world categories, and many scientific categories, cannot be cut and dry in that way. There's a famous scientific category that can't, the notion of species in biology. You can't make criteria to distinguish species. There's always some things that you would want to differentiate that the criteria says you can't, or vice versa. Now, as an example of a cluster concept, and I think there's a really good one that Lakoff chose, is the concept of mother. So when we hear the word mother, there's a lot of related but similar ideas. The birth mother, the genetic mother, the female caretaker of the child, the wife of the father, and so on. And there's a temptation to say, well, yeah, let's talk about what the essence of real mother is. So yeah, mothers usually have these properties, but to me a mother is really the person that raises the child, for instance. And the problem is that this actually doesn't accord with the way that we as a society on the whole use mother. So if you look at different dictionary definitions, they place different ones as the primary definition. And they also, if you look at expressions like I was adopted, so I don't know who my real mother is, or I am not a caring person, so I can never be a real mother to my child, they're actually using real mother in contradictory ways. So mother is an example of a cluster concept where in normal circumstances, there's a tight congruence between these things, and it's a useful bundle to talk about. But we are aware that none of them will capture all mothers. There are going to be mothers that are missing one or two of these things, and it's not that unusual when that occurs either. What I propose is that a proof perhaps can be defined in a similar way. That proof could be a convincing argument, a surveyable argument that gives you some type of insight, an a priori or non-ambulative argument that's essentially not making any assumptions, a transparent argument where every gap could be filled in, an argument within a particular representation system, and a socially sanctioned argument. And I won't go through this for the sake of time now, but I could argue that none of I could find you proofs that violate every one of these, but that are accepted by proofs as by the math community. But the ones that are the prototypical proofs actually satisfy all of them. And to end on a provocative note, I want to argue that it might not be the case that proof is the best concept to use for the purposes of math education and K-12 mathematics at all. So for mathematicians, proof is a good cluster concept because these things are so tightly oriented. So instead of having to say a convincing, deductive, socially sanctioned argument, we just use the word proof, and the presumption is, in that case, that it's going to fit all those criteria, and we would probably give some type of signifier if we were talking about a special type of proof, like a like a heuristic proof or an unpublished proof to denote that this meets some but not all of them, a computer-assisted proof, and so on. With students, we have no reason to assume that these things down here are so tightly correlated, and in fact, we know they're not. And so one thing to think about, might it be better if we avoid using the word proof because it's used in so many different ways and it's leading to contradictory results in the literature, and instead talk about getting students to make convincing arguments, deductive arguments, reaching social consensus in arguments, and so on.
I like the last point that you left us with about switching to convincing arguments, but doesn't it sort of continue the problem, though, in that now argument's the confusion as far as the term? I mean, in that sometimes students you'll say, what if I just multiply by 10 and get rid of all the decimals? But if the answer is a decimal, eventually you're going to get to the decimal, right? So if the concept is the fuzzy, confusing part, is there a word or a definition?
Okay, so just to be sure I understand the question, you're saying maybe convincing argument is just as loaded as proof is. I'm just pushing it down a level. I actually think you could get at convincing argument a little more precisely. This would be a convincing argument just off the top of my head. So that's an individual psychological construct. So this is an argument that an individual student would use as a warrant to accept a claim as true for some other action. And you're always going to get some type of fuzziness, right? I don't think that would invalidate the claim. I wouldn't say that we shouldn't use the word tall in the English language because people might disagree on whether I'm tall or above average. There's always going to be some type of middle ground. But I think with convincing argument, here you're putting it squarely on in the individual psychologically. So that is, I think, an improvement to the other one, where sometimes the proof is based on the nature of the argument, sometimes it's about a community, sometimes it's about an individual, sometimes it's about the deduction, how much is filled in, and so on. So maybe it wouldn't get rid of the problem, but I think it would make it better.
So I noticed that you were using the proofs and proving interchangeably. So how do you define the relationship between proving and proof?
Good. That's a perceptive comment. Reviewers yell at me all the time for that. So I was using the term somewhat interchangeably, wasn't I?
That's what I mean.
Not everybody does. Yeah. So apparently I'm a slow learner because I haven't been able to weed that habit out yet. From my own perspective, without saying that this is a good one or anyone else should adopt it, to me, proving is an attempt to produce a proof. And again, since proof has so many facets, making a tighter argument or making a more coherent argument or trying to build some type of understanding within a community would all fall under the broad activities of proving.
Thank you for sharing some of these thoughts. I'm really excited to think about it, especially as I am a teacher of pre-service, elementary school teacher. And the example of why a negative times a negative is a positive number comes to mind. And thinking about the types of arguments that they would give. Because a bad guy and a bad guy fight in an alley, and that's a good thing. So I guess my wonder is, doesn't it matter what the purpose of the proof or determining process is? Because sometimes maybe it depends on what the use is, so what kind of depth you're going into. And so I was wondering if you could share your thoughts on that.
Oh yeah, that is actually a great example, a great context. So the thing that often sticks with people, students and parents I've worked with, is a negative times a negative being positive is some analogy like you're removing debt is the same thing as gaining money. And so this would be, if we kept the construct of proof here, we could argue till we're blue in the face about whether that's a proof or not. I mean, it is a proof in some senses, but not in others. But this would be a thing where this is giving that type of example would be a convincing and insightful argument, but it isn't one that makes explicit premises, and it's not deductive or non-ampliative. There's obviously a lot of assumptions about what debt is that's not defined and so on. So, yeah, I mean, I think that we might be saying the same thing in two different ways. That more to the point, like the things that I was listing as important for proving, the ones that are most paramount would depend on your epistemic aims.
Thanks for listening to this special episode featuring Keith Weber from Rutgers University. Keep an eye out for the next episode, which will feature a panel discussion from this same working group at PMENA. 2 quick plugs to finish up. If you're a teacher thinking about pursuing a master's degree in mathematics education, we have a great online program at the University of Missouri. You can email me for details or check us out at online.missouri.edu/mathmed. And if you're a teacher leader or a teacher educator who has constantly felt like there are not enough good online videos of secondary math teaching, then you should check out secondarymathvideos.com. Rob Wyman, a friend of the podcast, see episode 1315, is one of the people behind this website, and I plan to use it in my own secondary methods courses, so I thought I'd pass along the word to you, secondarymathvideos.com.